So today we'll be learning about real-time operating system, which comes under module 5. In real-time operating systems, we'll be learning few things about operating system basics, some definition of operating systems, goals, and few more services provided by the operating systems. You can see here in operating system basics, what is an operating system? Operating system is a program that controls the execution of an application program. It is an interface between application and hardware. So what is an operating system? It is a program. It's a program. What it does, it controls the execution of an application. So this program will control the execution of an application program. So this is my application program. Application program. The application program can be something like it may be a Word. It may be Word. So it can be a Word. It can be a PDF. It can be a video player. Those are called application programs, which is controlled by your program, the main program. That is nothing but your operating system. So we can say it as it is an interface between an application and a hardware. So you can say that it is a interface between an application and a hardware. So that is the main definition of your operating system. So what is an operating system? Operating system is a program that controls the execution of an application program. It is an interface between application and the hardware. So that is the definition of your operating system. So before coming to the goals of an operating system provides different types of services to different users. It provides services to the program like load of data into the memory, or allocating of disk for storage, or files are directed to open or read, and etc. So services like load of data into the memory, allocating disk for the storage, files. So these are all controlled by your operating systems, which is nothing but data access into the memory. Okay, coming to the goals. So major goals and functions of an operating systems, like effective use of a computer system, user convenience, ability to evolve. So if we see, an operating system is nothing but a software that manages the computer hardware. What it says? A software that manages the computer hardware. So what the hardware will do? Hardware must provide appropriate mechanism to ensure the correct operation of the computer system. What hardware should do? It should provide appropriate mechanism to ensure the correct operation of the computer system and to prevent user programs from interfacing with the proper operating of the system. Proper operating of the system. So if I take this is an hardware, and what it says, must provide appropriate mechanism to ensure the correct operation of the computer system. So correct mechanism is nothing but a set of programs which are running on the hardware. Okay. So this is the user program from interfacing with the operating system. So user program will perform a particular operation with the mechanism provided by the system. That's what. It's nothing but your special programs that is controlled by your hardware. Okay. So the other one is efficiency. So when it comes to efficiency is one of the parameters for use of computer systems. So efficiency is very important. Operating system consumes some resources during its operations. The resource can be a memory, the resources can be a CPU usage, and so on. It can be, as an example, like it uses CPU and memory at a time, or CPU is busy with some scheduling and memory occupation by instructions and required data. So there are so many things where your operating system uses resources during its operations. So this is controlled by your operating system with an efficient way, or you can call it in an efficient way. And an operating system makes a computer more convenient to use. It should be more convenient so that the user can use it. A user can use the system in a more convenient way. If the operating system cannot allocate the free available resources to a program, or it may over allocate the resources, then efficiency is poor. So if I say there is 1 MB of data, and 1 MB of data, if I am going to store in a memory, that allocation is of 2 MB memory allocation. The size, I am speaking about the size of memory block. Size of memory block. If I am trying to store 1 MB of data in 2 MB memory block, then only 50% is used, other 50% is wasted. So this has to be controlled by your operating systems, and it should not be a poor efficiency by the system. Computer contains different types of resources. Like we know, like one is CPU, the other one is memory, and also I/O device, devices. So while proper monitoring is required on these resources to avoid overheating as per your resource scheduling. We all know how the resource scheduling will work. Depending upon that resource scheduling, this operating system should take care how your CPU, how your memory, and how your devices are controlled. So this has to be monitored, and how much resources are used by the system. And there should be a special attention to be given for the CPU and memory. If a memory is not free, then the user cannot load new programs into the memory. Try to understand this. If the memory is not free, then the user cannot load new programs into the memory. Then what happens? The CPU will be busy with memory management. So always CPU will be in allocating of memory for the user. The other task will be in idle state. So this is called poor efficiency. This has to be taken care by your operating systems. Thus the ability of evolve of the system. Okay, hope you understood with efficiency of computer, user convenience, and it should be ability to evolve. User convenience means it will be very useful for the user interface, like your GUI, graphical user interface. It's a user interface for the user, like your desktop, to use the files or accessing the files or storing the data into it. So these are all comes under your GUI, graphical user interface. Okay. So next is task performed by operating systems. So what are the tasks it performs? So we will see to it. So first is maintaining the list of resources in the system. So what are the resources here? Whenever I speak about resources, it's nothing but memory. It's nothing but memory. It should make a list. How much memory is utilized, how much memory is available, how much memory has been used by the system. And it also need to take care if the application program has finished its job, the memory has to be returned back to its where it was called. So this has to be taken care by your operating system. There's nothing but your memory management unit, which is controlled by your operating system. Next, maintain a list of authorized users. So if I say this is my PC, so everyone use PC. How do we use this? By using user ID and password. So number of authorized users using the PC is important. So this is listed out and will be monitored by your operating system. So it uses a list of authorized users and stores all the information in your operating system in a memory. Next, initialization, the execution of a programs and a process. So how to initialize a particular program, when to initialize a particular program, and how to that in a process by the CPU. So that is controlled by your operating systems. So when to execute a program, when the process has to take care, and when it has to run. These initializations is controlled by your operating systems. Next, maintain resource usage list. Resource is nothing but again it's a memory. So how much memory is utilized, how much it has been used by which applications, and how it has to be returned back. These are all controlled by your operating systems. Okay. Next, maintaining resource allocation list. Sorry, it's the same thing. Scheduling of resources. So if I am scheduling a resource for a particular system, let us say here some of the schedulers. I have a program 1, program 2, program 3, program 4, and program 5. I need to schedule the programs to the CPU. So when I'm scheduling the information to the CPU, when I'm scheduling the resources to the CPU or a processor to the CPU, we need to consider about the memory. We need to consider about a memory. So whenever a process is given to the CPU, a certain amount of memory is released. A certain amount of memory is released. This memory is controlled by your memory management unit. This memory management unit, what it does, it will take care how much memory has to be utilized or it has to be given for a particular process to run in a CPU. So this is called scheduling. Scheduling of a resource, scheduling of a particular process to the CPU to do a particular job or to execute that particular process. This is scheduling of resources. Resources means again it comes to memory. Okay. Next is maintaining the production information. When I speak about maintaining the production information, it's nothing but the user information. The user information has to be maintained in a particular memory unit that cannot be accessed by others. So these are the tasks performed by your operating systems. Okay. Next, services provided by the operating systems, very important. So what are the services provided, how it works, and we will see. So first is program execution. Coming to program execution, before executing the program, it is loaded onto the memory. So always there is a memory. What I am doing here, before executing a program, it is loaded onto the memory. The information is loaded onto the memory by the operating system. Who does that? That is controlled by your operating system. Once a program loads onto the memory, it starts executing. Let us see once again. Before executing a particular program, before executing a particular program, it is loaded onto the memory by the operating system. Once a program is loaded onto the memory, what happens? It starts executing. Program finishes its execution with error or without error. It is up to the user for next operation. So as soon as it is stored in the memory, it starts executing. After execution, the execution can be right or wrong, or you can call it as whether it is with an error or without an error. Okay, without an error, that's not a problem. But the only thing is that is controlled by the user. Whether it is executed without error means no problem. If it is executed with an error means it has to be executed once again. So that is controlled by program execution. So hope you have understood with this. We'll come back to the next one. Next is input output operations. What is input output operations? Program is combination of input and output statements. When I speak about a program, it is having an input, having an output. Input and output statements. While executing the program, it requires I/O devices. While executing the program, it requires an I/O devices. Okay. OS provides this I/O devices to the program. Who will provide this? OS will provide the I/O devices to the program. So program which is going to run, it has the input and output. That is input output operations service provided by the operating system. Very simple. Okay. Next is error detection. So when it comes to error detection, error is handled to the memory, or it can be CPU or I/O. Memory can be handled by memory, like error is handled by memory, CPU, or it can be of I/O devices, and in the user program. Memory is full, stack overflow, file not found, directory not exist, printer is not ready, attempt to access illegal memory. These are the examples of error detection. So which are the error detection? When it comes to memory is full, or when it comes to stack is overflow, and when it comes to memory, again file not found, and also when it comes to memory, again directory not exist. Apart from this, printer is not ready. That is called as spooling. SPOOLING. It's called spooling, like buffering. So this is not ready. So attempting to illegal memory, the memory which is not able to access, you are accessing to a particular memory which is illegal, which is not allowed by the operating system. That is called memory illegal access. So these are called error detection files or error detection. So that is called error detection. This is identified by your operating system, and also it's called as services. Hope you understand this. Okay. Next is file and directory operation. Okay, user wants to read and write the files and directories. Always user tries to read and write the files from the directory. If I call this a directory, I have some files. I can call it as file 1, file 2, file 3 and file 4. So user in a directory tries to access files. User wants to search a file or directory, and he also needs to rename a file, or he may need to modify the file, etc. These are all controlled by the file and directory operations, which are nothing but the services. He can rename the file, he can modify the file, he can change the directory, he can delete the file. So these are all controlled by your file and directory operations. All these operations is performed by user by using help of operating systems. So if I want to delete this, means it's not possible directly I can delete it. I can only go through your operating system using your GUI. Graphical user interface, I can go there and I can delete that particular file if I want to. So that is controlled by your file and directory operations. Next, communication. Communication may be inter-process communication and any other type of communications also. Data transfer is one type of communication or two in between two processes. So if I take a system 1 and if I can take system 2, so the type of communication between these two, it can be of synchronous or asynchronous. So two processes of the same machine, or it can be of two processes of different machines. If I take a two process, it can be of the same machine or it can be of different machines which can run. This usually we call it as pipeline structures or pipe in a memory or a shared memory concept, socket and message passing or the different types of communications will be used. What it does, it can be a process can be of the same system or it can be of two different systems. It can flow through different machines by using pipe. Pipe is nothing but a type of memory communication, and it can be of a shared memory or it can be of a socket or it can be of message passing for different communication protocols. So that is about your communication, how your operating system is providing these services. Okay. Next is graphical user interface. You all know how it works. Graphical user interface means whenever I speak of GUI, it's nothing but a system, your desktop. Is a desktop. User interacts with the operating system. The user interacts with an operating system by using user interface. User interface is graphical user interface. So all your operating system provides user interface. All your operating system, it can be of Windows, it can be of Linux, it can be of Linux series, Ubuntu, Red Hat, so many series. Everything has a GUI which interacts with your OS to access the files. Command line interface, batch interface, these are the two interfaces used in your operating systems. Apart from GUI, you have command line interface and batch interface, which are the two type interface used in your operating systems. In command line interface, if you see, user enters a text command. He uses a text command to perform operations. But in batch process user files, a file containing a command for various operations. It can be of execution of a command or output to display onto the screen. So many. It can have a file which can have execution of a command which executes, or it can be used as a display for the system onto the screen. That is called a batch interface, and this is called command line interface. These are all interfaces to access your operating system, which is controlled by your operating system. This is called graphical user interface. So if you see, all the above services provided by operating system is only for single user. It's not for multiple users, it's for single users. If suppose there are multiple users in the system, the operating system provides some additional services, like a user having an interface. So at the starting, an admin can access, a guest user can also access. An admin can access, a guest user can also be accessed. So the services, if suppose there are multiple users in the system, then operating system provides some additional services. These services are resource allocation. One will be resource allocation, one will be accounting, one will be production of data, and security. What all it will provide? Let us see this in depth. So when I speak about number of users, if a single user is using the operating system, that's no problem. If suppose multiple users are using in a system, then your operating system should take care of few things. There may be a user 1, there may be a user 2. Two users. So the services has to be divided, or it has to be managed. So what type of services it will manage? Allocation. So it will allocate. What it will allocate? It will allocate memory for the user 1. Same way, it will allocate a memory for user 2. So memory 1 and memory 2. Two are also provided by the operating system. Now user 1 can easily use, user 2 can also be used a particular memory, or you can call it as resource. It can use. Apart from resources, there is one more called as accounting. So who is using it? It's called log files. So which are the files you are using? Which are the file is used by user 1? Which are the files used by user 2? Which are the files used by some other X users? So everything is noted out. Accounting. So user 1 will not use user 2 data. User 2 will not use your user 1 data. So there is a data protection. The third one is data protection. So what is this data protection? A user uses a particular location to store that data. I'll call location 1. So that location cannot be accessed by user 2. That is protected. So user 2 has a location called L2. I'll call as L2. This part. So this L2 cannot be accessed by your user 2. So user 2 cannot access L2. User 1 cannot access L2. User 2 cannot access L1. So the data has been protected. This is one part. Okay. Next is security. Security. Apart from two users, like user 2 cannot access to the account of user 1, or user 1 cannot access the account of user 2. That is one type of security. Apart from user 1 and user 2, let us say there is a guest user. Temporarily he will come into the system. He should not access either user 1 data or user 2 data. That is also protected and which is available by the operating system. So these are the things is controlled by your operating systems, which is that resource allocation, accounting, and protection of data, as well as security. So these things you need to remember. So what all we studied today? What is operating system basics? We learned definition. Operating system is a program that controls the execution of a particular application programs. It is the interface between applications and hardware. That we learned. Then coming to goals, the efficient use of a computer, how efficiently the computer can be used, how resources allocations need to be maintained. It should be user convenient. It should be graphical user interface. The user can conveniently use the system properly. So there is no problem with the users to access. Ability of all. So most of the resources and CPU usage has to be maintained properly in the system. Those are the goals. And coming to operating system task performed. So maintain the list of resources in the system. So how much the resource has been allocated, how much it has been used, and how much is remaining. So these are maintained by the operating systems. Then maintaining the list of authorized users. So which are the users, who are the users, who are taking care, who are using the operating systems. Then execution of a program and a process. So how you can execute a program, so what type of program it is executing, how much process is going on, how much the CPU load is going on. So these are the initialized by your CPU. Then maintaining a resource usage list, how much memory is used. It is same as your first point. Maintaining the resources, resource usage, resource allocation, then scheduling of resources, how much CPU is used, how much your secondary memory is utilized, how you can schedule the particular task, how it can be executed in a CPU. So these are all performed by your operating system. Apart from this, there is a protection. That is nothing but your authorized users. So who are the authorized users you are using? So user 1 should not use user 2 data, user 2 should not use user 1 data, so on. Same way, some of the services provided by operating system, program execution. So once the program is loaded onto the memory, it starts executing. That's what we learned. So before executing the program, what it does, it loads into the memory by operating system. Once the program is loaded onto the memory, it starts executing. So program finishes its execution with error or without error. It may be decided by the user. The next operation. So input output means for every input output for a program, there should be an input and output with the hardware interface that is provided by your operating system for a particular program. Error detection, we learned error detection is something like a file not found, memory is full, stack overflow, or attempt to access illegal memory, so on. These are called error detection that we learned. Coming to file and directory operations. When I'm speaking about file and directory operations, it can be you can change the directory, you can delete a directory, you can delete a file, you can store a file, you can store a particular file to the particular directory. These are all performed by your file and directory. The last part one, it's communication. The communication takes place between the two processes or in the same machine, or two processes and a different machine. It can be flow through pipe or shared memory, socket and message passing, or different methods of communication that is taken care by operating system. The last one is graphical user interface. What does graphical user interface use to? It is user convenience for the user to use the system. We call it as GUI, graphical user interface. There are two types. One is command line interface, the other one is batch interface. So what happens in command line interface? A user enters a text command for performing an operation. But batch is different. A file containing a command for various operations. It can have a file for executing command output to display onto the screen. So this is called a graphical user interface. Okay, so this is all about your operating system basics. The next class we will study about user and supervisory modes. Hope you all understand with the class. Thank you all.